Thank you everybody for joining in on another review club. And today we are reviewing PR number 27145, which is a wallet based PR, and it basically adds some extra behavior on the wallet regarding conflicting transactions, right? And so what this PR does is, like, the description is quite small, and it basically says what it does is, so when a block get disconnected in the blockchain, so in a case like when we have a reorg, so a previous part of the leading chain got changed into some other part of the chain because the node suddenly got notified of a longer blockchain. So the previous part of the blocks that were there in the orphaned block will get discarded, and including all the transactions that included in that block will also get discarded. Now the question was, what happens when there was a conflict between a transaction in an orphaned block and a transaction in the wallet? So in the case of conflict, Bitcoin Core returns that the confirmation of that particular transaction is negative. And the negativity is like, in case of like conflicting with a previous block, the negativity denotes like how many blocks before the conflict happened. So a negative 15 indicates like 15 blocks before there was a block that contained a transaction that conflicts with this particular transaction. So conflicted transactions aren't considered in the spending and the balance calculation part. So now the question was, when the block gets reorged. So suppose there was a conflict with a wallet transaction with a transaction in a previous block, say 5 block depth. Now there was a reorg of 6 blocks, and that block, including that conflicting transaction, got reorged out. Previously, that reorg wasn't going to set the state of that conflicting transaction, refresh the state of that conflicting transaction. So a transaction which was conflicted in a block that got reorged is still remain conflicted. So, but that's not the case, right? Because the conflicting transaction was in a block and that block got reorged. So the new blocks doesn't have those transactions anymore. So we should not consider this transaction conflicted anymore. So that was the bug, and that was kind of like a behavioral bug that was described in these very early issues. And this behavior was started from version 12, and version 11 didn't used to have this behavior. And Marcos already proposed a fix, and this was like attempted to be fixed in multiple different cases, and some PR got closed. And this is the final PR by Ishanam on the behavior of the change. And so basically what happens is, like, in case when the block gets reorged and the transaction isn't conflicted anymore, the transaction is marked as inactive. And an inactive transaction is a transaction that is inside the wallet and not inside a mempool. So it's not part of the balance calculation, and until that transaction gets rebroadcasted again. So that's the change here. So what
that is the current behavior, like marking it as inactive?
No, the PR changes into marking it as inactive. The current behavior is like, don't do anything. So if it's conflicted, it remains conflicted.
Oh,
right.
Okay.
So the current behavior doesn't do anything in case of block reorged. And this is being shown in this change set over here. So I guess this part of the code where we say like block disconnected. So previously in block disconnected, this was all that was there, right? Nothing happens on the transaction state. And this is the part where in the new code was added in case of block disconnected, and
Hmm.
this wallet transaction, it checks whether if it's conflicted, if it's not conflicted. If it's not conflicted, then it goes on, continues. But if it is conflicted, if the transaction state is conflicted and conflicting block height greater than equals to disconnection height, then meaning like the conflict happens on or after the block disconnection height, the point where the reorg started, then this
Hmm.
transaction state is changed to new state transaction state inactive, and it returns that transaction state has been changed. So this is the part that tells the new behavior where the wallet gets the wallet transaction state gets updated.
I did not know there was a state called inactive for transactions. Are there other states like that?
Yeah, I think that was added in this PR itself. It's inside this wallet transaction. Transaction update. Um, oh no, there are other states like that. Let me try to find that when the transaction state is inactive. So transaction state inactive. Try to go to the definition of this guy. Not happening. I guess it's taking too much time to load. So, transaction state inactive. So these are like the transaction states. So transaction state is in confirmed. So we have the confirmation height position in the block. Transaction state in mempool, it's sitting inside mempool. Transaction state inactive. It basically means like state of a transaction not confirmed or conflicting with a known block and not in mempool. So it's not confirmed, not in mempool, or not in conflict. May conflict with something in mempool or with an unknown block, or be abandoned, never broadcast or reject from the mempool, or for another reason. So this is the case that encompasses when the transaction state inactive. It can be like optionally abandoned or not. I think what happens is like when it's abandoned, then the wallet doesn't try to rebroadcast it again. But when it's not abandoned, which is by default, then the wallet will try to rebroadcast. And then there is another state, then the transaction state unrecognized. So these are the state of a transaction, like the 5 different state where the transaction can be in.
Interesting.
Yeah, so here where the block got disconnected, so they added this extra logic which takes the conflicting transaction state into inactive. And they also added few extra other things over here. So if we go into the chain set of wallet.cpp, there was a lot of code inside this part which got refactored into this guy. No, not this guy.
They put it into another function.
Yeah, they put it into another function called recursive state update. It's not very clearly visible because of the, yeah, this guy, this new function, recursively update transaction state. It's kind of interesting what they did over here. So previously, like abandoned transaction used to have this method inside it. So what this does is like for a given transaction, it recursively check all the spends of that transaction, right? So if the parent of that transaction state got updated, so the parent of the transaction got conflicted, right? So all the child transaction will also get conflicted.
Yes.
So here they in this function they take in lambda, and this lambda basically denotes like how the transaction state will be updated from for child transaction. So there is one lambda for mark conflicted. So given a transaction, mark this transaction conflicted and mark all the child transaction of this transaction conflicted. This is the lambda that is used over here. And this is abandon a transaction. Given a transaction, abandon this guy, and like abandon all the child transaction of that guy, of that transaction, abandon too. So recursively update state transaction now can take like custom lambda that changes the state of that transaction depending on what situation we are in. Are we trying to abandon it? Are we trying to make them, mark them as conflicting, and things like that? So this is one major change that got added into this PR. And so moving back to our questions, so this is the lambda that we talked about, and why we want to mark transactions recursively, because the child transaction state also depends on the parent transaction state, right? If the parent transactions got marked into something, that also means like the child transaction also have to get marked similarly.
Yeah, makes sense.
Yeah. And the third question was also something that we discussed. What is the block disconnection logic achieving here, which is this part of the code that we just saw, is like making the transaction state conflicted when a block get disconnected. So we basically check inside that block for all the transactions inside that block. We check whether any of our wallet transaction was conflicting with the block of the transactions of that block. And if it was, then the previous transaction state get inactive.
Hmm.
And then the wallet can choose to rebroadcast that again. This was a very like very narrow edge case where a conflict happened with the orphaned block and the behavior wasn't consistent. What happened when that block gets reorged out? So very small chance of this happening, but it still can happen.
Hmm.
Can you hear me now?
Yeah, yeah,
Yeah.
we can hear you, we can hear you. Welcome back.
Yeah. So I have so inactive and abandoned is it same?
Inactive and abandon, is it same? I think that answers by this question with state. So a state can be inactive without being abandoned. So when a transaction state is inactive, it by default says abandoned equals to false. And when abandoned equals to false, uh, then it will not rebroadcast it again. Maybe we can try to find that logic over here. Transaction state inactive.
So that means like a new transaction which we just created. That is inactive.
Uh,
How can there be an inactive transaction?
so inactive transactions are transactions which are inside the wallet database but not inside the mempool for whatever reason.
Okay.
So this is the document of that inactive state describes this: a state of the transaction not confirmed, not conflicting with anything in the block or not in the mempool. So it's not in mempool, it's not conflicting, it's not confirmed, it's inside wallet database but nowhere else. So until and unless the wallet choose to rebroadcast that transaction again, that transaction will not go inside the mempool. So in that case, we will like consider that transaction as inactive.
Okay. I have one more question
Mhm.
regarding this rebroadcasting. Like when does the wallet do this automatically? So I think is
Mm.
there some time period or
Yeah, I think the time period is around 24 hours or something like that. It's gonna be hard to find that logic, but let's try to find that logic anyway. Rebroadcast. Resubmit wallet transaction. Um, Optionally asking the mempool to relay them on startup will do this for all unconfirmed transaction, but will not ask the mempool to relay them. We do this on startup to ensure that our own mempool is aware of our transaction. There is a privacy side effect where here as not rebroadcasting on startup also means that we won't inform the world about our transactions. Okay, so this is like resubmit wallet transaction. So when is this guy called? Maybe recent wallet transaction. So if P wallet should resend, then continue. If not, P wallet should resend, then continue, then resubmit wallet transaction, set next resend, and set next resend, get default next resend. And this guy is
It should be some configuration
some
variable.
configuration.
Okay.
Set the next time with the wallet should resend transaction to 12 to 36 hours from now, around 1 day on average. So it basically like randomly chooses between 12 hours to 36 hours to
Okay, okay.
rebroadcast transactions.
Which
And
transactions? Our transactions.
wallet
Oh,
transactions, our transactions, yeah, the transactions which are inside the wallet database but not in mempool.
oh,
Right, so it's for some reason it's like inside our wallet database but it not in mempool, or maybe got dropped off from the mempool due to mempool size limit or something like that. And after some time the wallet basically checks whether all its transactions are in mempool or not, and there is a flag called should resend, return true if all conditions for periodically resending transactions are met. And Mm, so there is a if broadcast transaction flag, chain is
hmm,
ready to broadcast, and note clock is less than next resend. Note clock has to be more than next resend time. Then
hmm.
the wallet should resend transaction. And this is that next resend number that we just check, which is get wallet default, and which is this random uniform random delay from now from 12 hours to 24 hours. And so it randomly checks for resubmission into the mempool from 12 to 36. I guess the way it works is like from now plus 12, then 12 plus 24, because it said like around 36. Okay, yeah. Time is like now plus 12 hours, and the range is like from that time to 24 hours. So 12 plus 24, 36. So around about average of like 24 hours, it will try to like rebroadcast transaction. Yeah, so that's what it means by transaction state inactive.
Yes.
And yep. Any other question till now? I lost where was our um in part of the PR.
I think we were discussing the
Blog disconnect.
questions.
Yeah, we were discussing the questions, and um, yeah, so block disconnection logic was there. So block disconnection logic basically is like the newly added code over here that basically says like that's what it does. It changes for transaction conflict with orphaned block. It changes the transaction state into inactive. And yeah. So what is next question is what is map transaction spans and what it is used for. So map transaction spans is the structure over here. Find that out. Emily, you want to go ahead and give a shot at what max transaction spend is? What is this structure? This is the
Uh,
definition of the structure. And transaction spend is an unordered multi-map of outpoint and unit 256. So yeah, basically like this document describes it. It's basically a map of all the transactions that spends a known outpoint. And
oh. So if there's more than one, it's marked as dirty or whatever. Is that what it is? Or
I guess like the dirty thing comes in play like when a transaction input gets spent, when an outpoint gets spent. And yeah, that's a good question, like mark dirty. Um, there could be um like in theory, like uh, you can have like multiple transactions spending a single outpoint. That means like it's a conflict, right? um, a
yes,
single outpoint should not be spent by multiple transaction. If we have a situations like that, then that denotes a conflict. And I'm not sure whether the map transaction spent logic takes in from there. um, so here it is used in the block disconnection is saying like for this transaction in block vector transaction, for each transaction inside the block, for each transaction input of that transaction, if our map transaction spends count for that input is less than 1, that means like no other wallet transaction conflicted with this transaction. So nothing to do with this transaction, just ignore and continue on the next one. So in this way, we basically say like if our max transaction spend count for these transactions, like what happens if this is 0? I don't know. Like if this is 0, then it means like
it should be in our wallet, I guess, like wallet balance. I mean, if it's ours,
hmm
not spent.
yeah, so inside this map, if the count of this previous output, okay, so this is a map, and the map is this guy is an C output and given a transaction hash. If we have like multiple transactions, or I think this count standard size t number of elements of that, it gives us the number of elements given with that key. And if the count is less than 1, what does it mean by count less than 1? Stratosphere, any C++ help here? What does it mean by count less than 1?
Okay. Count means like, do we have that key in map transaction spends? How many times do we have that key, which is
Okay.
transaction in dot prevout in map transaction spends?
Okay. And okay. So if there is like the key isn't there, then it will turn as 0.
Yeah.
Okay, so that will be less than 1. And if the key is like there, then it's like it will be equal to 1. Then
Yeah.
we will have an wallet transaction that conflicts with this block transaction. Okay, makes sense.
So if we have a wallet transaction conflict, we'll go to the next line of code.
Yes. If we have a wallet transaction that conflicts, we'll go to the next lines of code. And this is where the changes will happen. And
Yeah, for all of the spends that conflicted this transaction.
yeah.
I think also it's possible it's the same transaction, right? So I think that's why we have, if it is not conflicted, we continue.
Yeah, so if that transaction isn't marked as conflicted previously, then it will just continue. It can be possible that, yeah, we just have that block transaction in our wallet.
Yes. Yeah.
Yeah. So what was the question that we were discussing? Map transaction spends. So yeah, basically map transaction spends is this transaction that basically is a map of out point and the hash of the transaction that's spending that out point. And it's useful to track all the spends of the wallet, and some of the spends get confirmed, some of the spends doesn't get confirmed, and depending on like the state of that various transactions, the wallet will calculate different balances. Yeah. Any other questions so far on this part? Okay, the next one is kind of like simple. What does it mean like exclusive lock required CS wallet? What does it mean by this exclusive lock required thing? You will find this guy many places around the code base, not just in wallet, in node, in P2P. There is like these things called exclusive lock required. Anybody wanna like chime in? What does it mean?
It's so that like when you enter into that function and perform some operations,
Mm-hmm.
like if some other thread is executing another set of operations which require that same lock,
Mm-hmm.
we shouldn't do it in case there is some inconsistency in, like if both those threads were using same variable and we
Yeah.
were changing those, there
Yeah,
would be
so
inconsistency.
this CS wallet, or like this CS node, CS other things, these are called critical sections, and they are basically recursive mutex. And this is just a variable which is like a lock. So any thread that is marked, any function that is marked with exclusive lock required on CS something, they have to lock in on that lock first. So here's like block disconnected was marked with exclusive lock required. Um, if we go to the definition, can I go to the definition of this guy? So anyway, like block disconnection in the wallet.h will have like exclusive lock required, and this is like lock CS wallet. And until and unless it can lock CS wallet, the rest of the functions will not happen. And this is used to maintain consistency of the wallet state. It's like the Bitcoin code is multi-threaded, right? So there are like multiple threads going on in parallel, and different threads are asking for like to do different operations on the wallet node and different parts, and they cannot do operations simultaneously, so they have to do one at a time. So when one thread is working on the wallet, the other threads will wait until the lock is available, and then it will lock, and then it will do its thing.
This is race condition, right? This wouldn't
Yeah.
happen in Rust
Yeah,
and all.
yeah, like in Rust, you can still have race conditions, and there is the concept of mutex and mutex guard and RW lock and all these kind of things. So on multi-threaded cases, when there is a possibility of mutex race conditions, you will like wrap the structure inside the mutex. So unlike C++, where this mutex is its own thing on its own, in Rust what you will have is like probably like this wallet structure will be wrapped inside mutex, and it will look like something like this arc of an wallet, um, a structure like this. And then you will call like so maybe locked wallet will be this, and then you will call like locked wallet dot lock uh, in order to get the lock on the wallet, instead of like having an individual mutex floating inside. But the concept is same over there.
I saw some command last week to see all the threads. Like if you're running Bitcoin D, there's some command to see all the threads running. I don't remember it now.
Oh, that's so sad because that would be fun to look at. Uh, in Bitcoin CLI or in Bitcoin D?
It was in Bitcoin D. There was. Oh yeah, yeah. It's okay. Oh, I found the link.
Okay.
Uh,
Would it be
it's
cool to
something.
like
It's something called
type
Hedgetop. I think it's another utility. I
H
saw
top
someone. Yeah.
like this guy? But this is like a system monitoring tool.
Yeah, using that, I do not know how this person just displayed the Bitcoin thread CPU usage. I'll actually send you the link.
Hmm. You can send it here in the chat.
Yeah. Mhm.
Okay.
They got all the threads using some command and the CPU usage for each.
Okay. According to the poster screen, we could go to the display setting, reachable via F2, activated tree view, global option, show custom thread names, and this shows the CPU usage per thread. Uh-huh. Okay, let's try it out. Hmm, let's see. Over there. Um, so H top and saying like reachable via F2 and activate tree view and the global option show custom thread names. Okay, F2.
Tree view.
Huh.
No.
Uh,
Oh
tree
yeah, tree
view.
view.
Okay.
Push show custom thread names as an option too.
Show
Down.
custom thread names. Okay.
Okay.
Um, okay. Uh, okay. Maybe we can say um H top. Where is Bitcoin D? We need to find the process ID of Bitcoin D that is running.
There's no grep or anything for this.
No. Um, eh, who wants Windows?
Uh,
Yeah, this
there's
command. Okay, this guy. And if we do h top help, there is this call PID. So h top p, this guy. Okay, Bitcoin D, Bitcoin D, Bitcoin D. But we don't see the thread names. So display option,
Okay.
preview.
Show custom thread names.
This is Bitcoin D. Okay. Uh, show custom thread names. Yes. Okay. Huh.
Oh,
So there is a scheduler, there is store control, net add connection, message handler, script.h, and yeah, these are the CPU percentage and memory percentage, I guess, for each one of them. Cool.
nice.
Nice. Yeah, I didn't knew that. Thanks.
Yeah, I mean, I wouldn't do it. Thanks for showing.
Yeah, yeah. Well, it's always fun to try stuffs out. Okay, cool.
Yeah.
Nice to know. Our Bitcoin D is still running. I think, yeah, it's Signet. Yeah, so we are running Signet and it's synced. Good. Okay. So what was the next question? Exclusive lock. We covered exclusive lock. Exclusive locks are nice things to have. So the next one was on the approach of the test function. Like what was the test function approach that they taken? Emil, have you taken a look into the test function?
I didn't go through the code. I was going through the comments, and
Mm-hmm.
that's when I think I saw that the rebroadcast thing. Can we write the test for the rebroadcast scenario?
Right.
I haven't gone through the code.
Uh-huh. I think like yeah, she already added a test for the rebroadcast scenario. The test is not that hard. It's interesting. So what they're doing is like they have three nodes. Node number of nodes is three, and they are selling the first node to create two transaction. Transaction ID conflict one, conflict from two. So these are the two transactions that is being created, and then it's creating a transaction that is spending the output of these two transactions. So transaction AB parent is like has two inputs, one from one output from the transaction one, another output from the transaction two. So and then it creating a child transaction which is um, so which is a transaction that is pending from that AB transaction, AB parent transaction, right? And then it's creating the conflict. So AB spends from transaction 1 and transaction 2. Now it's creating two other transaction. Transaction A1 spends from transaction 1, transaction B1 spends from transaction 2. So in theory, transaction A1, both transaction A1 and transaction B1 conflicting with transaction AB parent transaction. Make sense?
Yeah.
Yes.
Yeah. So it creating these two transaction. Then it's broadcasting the AB transaction. After broadcasting the AB transaction, it's getting it confirmed. And then it's creating the child transaction, this guy, which spends from one input from AB transaction. And then, so it has like only one input, TXID of AB transaction, and it's only one output. And then it spends to the node address some amount, and then it sends that raw transaction. Now what it does is like it tells node 1 to broadcast the conflicting transaction. So tx1 txa1 and txb1 conflicting with this guy, so it's also conflicting with this guy, right? Because this is a child of this transaction. If this transaction get conflicted with this is also getting conflicted with this, right? Because its parent is conflicted. So Instead of asking the node 0, it's asking the node 1 to send the raw transaction. And before that, it got the two nodes disconnected. So node 0 and 1 is disconnected, node 2 and 1 is disconnected. So node 1 has no idea of like this AB parent transaction because it's disconnected from node 0. So node 1 happily broadcasts and sends the node transaction 1, transaction A1 and transaction B1. And now we connect these two nodes and sync their blocks, right? And if we ask for the AB parent transaction and AB child transaction, then we get the conflict, like this conflicted AB transactions. And so basically node 1 had like 4 blocks on top of extra. So no, previously before disconnection they all were on the same tape. Then node 0 created one more block here, one more block here. Node 1 created 4 block here and 4 block here. So node 1 is ahead of node 0. And when node 0 and node 1 got reconnected and sync block was called, then node 1 will basically reorg node 0. Makes sense? Because
Makes sense.
nodes 1's blockchain was larger than node 0's. Node 0's last 2 block will get deleted and node 1's 8 blocks will get into node 0, right? Now node 0's last 2 block had the AB child and parent transaction, like the AB transaction, AB parent transaction and C child transaction. But node 1's last 8 blocks did not have those transactions. So when the reorg happened, the AB parent and the child C got reorged out of the blockchain, right? And that's what is showing in this conflicted AB transaction. So so when node 0 is being asked of like, hey, what's the status of like the AB parent transaction? It's saying like it was in a block, but that got reorged out. And now it is conflicted with a transaction that is inside a block, which is transaction A1 and B1, right? And so that's why its confirmation will be less than 0. Right? And so here transaction A was accepted and transaction AB wasn't, right? And so conflicted AB transactions confirmation and the confirmation of transaction A is basically same. So the conflicted confirmation is like the negativity is like the number of block by which it got conflicted in. So transaction A conflicts with transaction AB, and transaction A's confirmation, if transaction A is confirmed by 10 blocks, then transaction AB will be like confirmation will be like minus 10. It means like transaction AB is conflicting with a transaction that is 10 blocks deep from the tip of the blockchain right now.
Oh, interesting. I didn't know that.
Yeah. And then it's checking bunch of more confirmations of different types, and now generate a longer chain that does not contain any transaction. So it's saying transaction node 2. Now node 2 was disconnected from node 1. So node 2 has no idea of these new 8 blocks that got mined. So it's saying node 2 generate 15 more blocks. And when node 0 and node 2 get connected and syncing block, that's another reorg. So node 1's blocks now get reorged out by node 2's block, right? And nodes 1 block had the transaction 1 and transaction 2, transaction A and transaction A1 and transaction B1, which was confirmed in these blocks. Now they get reorged out. So now AB parent has a confirmation of 0. So previously AB parent was conflicting on node 0. But now AB parent has a conformation of 0 because the conflicting transaction that was in the blocks of node 1 got reorged out by blocks of node 2. So AB parent's state of conflict got changed. That was the point of this PR, right? So AB parent, so these names are very confusing. So this is like the transaction for AB parent, and the conformation for AB parent now is 0. Previously, this was negative. This guy was negative and this guy was some minus 15 or something, like minus 8 or something like that. Now, because of the reorg of node 2, this got 0.
So this transaction became inactive or something like.
Yeah, the transaction basically became inactive. It's sitting in the wallet and its conformation turned into 0. So it was previously marked as conflicted. So it was conformation was negative. Now it became inactive and its conformation became 0. And now this wallet can like send this raw transaction again and rebroadcast this transaction, and this transaction gets confirmed, and on another block was generated by node 2. Blocks are synced, and this transaction which was formerly conflicted now has a confirmation of 1 because it got into this block. Right, so this is where it's happening. It's like previously the confirmation was negative because it was conflicting with a transaction in a block that came from node 1 in this step, and then node 2 created 15 more blocks. Where was that? Node 2 created 15 more blocks that reorged out node 1's block, which had the conflicting transaction A1 and B1. So the AB parent is not conflicting anymore because the conflicting transaction is gone from the blockchain. And so AB parent's new transaction status is like it has confirmation with 0. And confirmation with, it doesn't actually state like whether it's inactive or active or abandoned or not. It basically says like confirmation is 0. It means like it's not in the wallet mempool. I'm not sure whether it's in the mempool or not. Maybe we can check that. But it's basically say like it's not inside any block, and majorly it's not conflicting anymore because the conflicted transaction TXA1 and B1 got reorged out by the new blocks. Does that make sense?
Yes. So like this, like previous to this PR, all these tests would fail, right? From 115, they would fail.
Yeah. That was the next question. Like, what happens when you run this test on master? Any guess? What will happen when you run this test on master? We'll do that right now. But before I just run it, maybe take a guess.
Yeah. Oh, yeah. Okay. I think my guess is that from 115, the confirmation it will be still negative, right?
Okay.
A session failure.
Yeah. That's basically gonna happen. I have like the master branch compiled over there, so let's just run this test. Boom, minus 15 not equals to 0. And this is happening on line number 115. So it has a confirmation. Previously, even in the case of reorg, the conflicted transactions confirmation status wasn't changing. That was the bug, right? So the previous transaction TXA1 and B1 got reorged out, but AB parent is still marked as conflicted. Right? And its status was returning minus 15. So that's a pretty niche and curvy edge case over there. Can happen, but so far I don't think like anybody reported it happening. But yeah, some people found out from the code that there's a behavioral problem.
So this needs two reorgs, right? One for it to be conflicted first, and then it has to be like inactive again. So two reorgs should happen, I guess, recently.
Uh, what do you mean? No, conflict doesn't require a reorg, right? So if one transaction is in block and another transaction inside the wallet, then these two transactions are conflicting with each other,
Oh, okay, yeah, okay, yeah.
right? And the state only need to get updated when there is a reorg, and because of the reorg, the conflicting situation isn't there anymore.
Oh, yeah. So a wallet could have conflicting transactions, like just because the person built it with that. That makes sense. It doesn't need a reorg.
Yeah. The wallet can totally have conflicting transaction just because the person built it that way. Or like two wallets simultaneously try to spend one single input from two separate database, and then broadcasted it independently. That can also happen. So you have one wallet in one machine, another wallet in another machine, but they all have their same wallet basically, so they are all have the same input, and you create transaction from one guy, at the same time you create transaction from another guy, and they use the same input. They don't know about others transaction until and unless they both broadcast, right? And they only know about the conflict when they broadcast that transaction.
I have a doubt then. So if input, output, fees, everything is same, will the transaction hash be same?
If inputs, outputs and everything be same, then the transaction hash will be same, given that the other fields like the lock time and all these fields are same.
Yeah. So if two wallets, they can theoretically make the same transaction, right?
If they are of working with the same private keys, yes.
Okay. Yeah.
So every wallet like have a database of their available inputs, and that depends on what are their private keys, like the inputs that they can sign for, and they will only select same input if they can sign for the same thing. That means like they have the same private keys inside them. That means like they're, yeah, essentially same wallet.
Okay. Yeah. So basically, I mean, two what you say, there are different implementations, right? So two wallets can theoretically choose the same like UTXO. Yeah, okay, wait, yeah, this is something.
And but you will only have that situation if both the wallet has the same seed phrase, meaning like both the wallet somehow sign for the same thing, and that
Ah, yeah,
generally doesn't
right.
happen because
Oh
you
yeah.
have seed phrases different in different wallets. So by theory they will never be able to sign for the same thing. But if you import the same seed phrase into two different wallet, then they will be able to sign for the same thing, and you can potentially have conflicts.
I mean, then it isn't a conflict because they're the same transaction.
Yeah. Then there are, like if they are exactly the same transaction, then it's not a conflict. But the wallet can choose to like create transaction differently. For example, you have like 10 UTXOs, right? Among them, this wallet select 3 of them, this wallet select 5 of them, but one of the UTXOs are common. So that's a conflict, but the transaction hash will not match. These are different transactions, but trying to spend from the same UTXOs. And
Ah, yes. Yes.
so in that kind of situation, most of the cases
Yes.
you will be very unlikely that you will end
Yeah,
up
yeah.
with the same exact hash.
I guess the parameters will, the fees will be different and stuff
Fees
like
will be
that.
different. Yeah. Okay, we are almost at the end. Yeah, that was our last question. How does this test fails in the master branch? And with that, we are at the end of our this week's session. Wasn't too bad, I guess. We were almost at the verge of dropping it, and Stratosphere came and saved the day.
Oh God, no.
Yeah. Keep saving us like that. So yeah, any
Yeah,
other
what?
question?
The last thing you discuss kind of, I don't know, like what is the guarantee that the wallets we buy have different seed phrases?
What is the guarantee that the wallet will have different seed phrases? Um,
I mean,
if
if Ledger wanted to, oh wait, I didn't say any name. I didn't say any name. Okay, go on.
okay, yeah, so like you can only have like same seed phrase in a wallet if you like manually import the same seed phrase into it. If the wallet regenerate the seed phrase for you, if the wallet generates the seed phrase for you, it's like what are the chances of like the two wallet like bangs on exact 256-bit number randomly? um,
Ah,
Chances are very low. So if you generate wallet in the same phone, like two different apps, even like one app two different wallet, like for example Blue Wallet allows you to do that. You can have multiple wallets in the same app, they will never have the same seed phrase. It only
yeah.
happens when you manually import them. Yeah, go
I
ahead.
mean,
And
or it could
usually
be
every
very
new wallet. Oh, go on.
yeah, and or it could be very bad code, like the entropy could be set to like the time of the phone or something, and then two different people at the same time if they make like
Yeah, something stupid like that has to happen. Yeah, otherwise it's like impossible to get the same seed phrase.
And usually seed phrases are always regenerated when we buy a new wallet, right?
Yeah, until and unless you are restoring a seed phrase into a wallet. For example, you have a seed phrase that was generated by Treasure. Now like you want to restore the same seed phrase into Cold Card wallet, you can do that. But that
Hmm.
requires manually restoring the seed phrase into the wallet. But then that kind of situation can happen, that Treasure and the Cold Card can create transactions which are conflicting with each other. Okay. Any more other wallet related conflicts or any other questions?
Thanks for hosting.
No
I learned a
problem.
lot.
Yeah. Looking forward for your sessions also. So thanks for joining in and saving the day.
No, my head is only at SecP. Unless you all want to listen to SecP code.
We all want to listen to SecP code. We should have a
yes, yes,
we
yeah.
should have a review club on SecP. That will be fun. That would be really fun.
Okay, you need,
So that is the elliptic curve library, right? That is SecP,
yeah,
right?
Yeah,
Okay.
yeah. The engine that powers the entire Bitcoin cryptography world.
yeah.
Okay, thanks for joining in, stopping the recording for today.